Ladies and gentlemen, welcome this afternoon to our talk about the configuration management at Deutsche Bahn, German National Railway. And the subline is the CMM4 managed environment for data centers. And I'm really happy that my friend and colleague Marcel is here to join us. And he is a founder and CTO of a couple of companies. Also Cirrus and Circles, his current company he's working for, and he also worked for companies like Deutsche Post, Deutsche Bahn, and lots more. Yeah, I'm Axel Morkner. I'm the co-founder of Structr and current CEO. So Structr is a little tool based on Neo4j, on top of Neo4j. We'll come to that a little bit later. And I think, yeah, Marcel, we'll just start right away and tell us a little bit about the challenges at the Deutsche Bahn in configuration management and data centers.
Yeah. So let me ask, who of you is working for a big enterprise which has an own data center? Wow, wonderful. So at Deutsche Bahn we had a little bit of a problem because we're going to sell one of our core data centers. And the plan is to migrate the applications from our data center maybe into the Amazon cloud or any other cloud. This is quite a challenge because most of our software is not really cloud ready. And we have also software which is basically not even scalable or something like that, what you want to have in the Amazon cloud. It's even worse. We have basically all kind of technologies. We mixed for our service-oriented application platform the complete software stack of Software AG and TIBCO, and this is very, very complex enterprise middleware software, and it needs for one stage, so we have 4 stages: development, integration, then the environment where we put everything production-like together, and then the real production environment. And to set up one of these kind of enterprise integration platforms for ZOA, we need about 30 dedicated servers just standalone. And these are often on dedicated, cloud-ready platforms. And now we want to go to infrastructure as a service, platform as a service, and software as a service in the cloud. And our current applications are mainly installed while people looking into Word documents and write down, open this web page, go to this kind of element in Software AG, click here, this, and then try to figure out your URL where it is, and then install the software. So a software installation can take days for a single person. And so for every application, there's a single person responsible to reading all the documents to install that stuff. We are in the business track, but the problem which we are solving is a highly technical problem. And what is so complicated on software installations? Most of the things get complicated and messy because the business people don't look what the guys are really doing. We have many external guys, and with the external guys we have the issues that we have the installer binary. Then somebody created a shell script to execute the installation. Another consultant later on came and said it's better to use ANT, it's more modern. And then somebody came and says, I don't know ANT, we need to use Maven or Jenkins. And we get a hell of a mess of things to install software and have to really get rid of this kind of weird things. It would be lovely if everybody would come with a package manager and we could just write a name of a software which we want to install, and then the package manager installs it. So that's basically state of the art. But how many of you did write self-written applications? Who created own applications in their company? And is your own written application available through a package manager? At least one. But you see, this is a problem. This is how operating guys want to work. They just want to automate that, but most of them don't. But now, in our stage, we install one application in a middleware environment with 30 servers on one stage. So how to do that with a package manager? Does anybody know any package manager who can do that? So the point is, a package manager does not really know what is a distributed application. It just sees the one software package. And if it's even an application distributed across multiple computers, the notion of application or even cluster gets highly complicated. And there's tons of tools in the market to try to figure out this, but there's no real good standard around there. So we were completely lost in complexity when we were in front of the problem how to migrate all these kind of applications, mission-critical applications, in the next 2 to 3 years in the cloud. So because of all the kind of mixed technologies, our config and change management ticket numbers exploded, and we need to have for every technology somebody who still knows how to do it. So there's a hell of a lot of people involved. And there's no notion of application in the installation tools. Yeah? An application is a bunch of processes on a bunch of machines in maybe even a bunch of locations to be fail-safe. Yeah? So, but when one of these kind of processes goes down, which application is really affected? Do you know that? And is there a standard to do that? And who will be impacted? Which customer can't do his job anymore because this kind of application is down? And if we want to migrate to another bunch of servers, how much capacity is needed on a new host? They don't know all of these things. And how to recreate an identical configuration somewhere else where all the IP addresses and stuff are naturally different. So on the one hand, the configuration will in any case be different, and on the other hand, you have to guarantee that it is identically. So how to do these things? And if you look into software lifecycle management and what kind of tools are there to manage the lifecycle of a software, you get lost in zillions of tools which you can choose. And they all have their different kind of notions and ideas. And even if you try to limit yourself to the new hype topic being a DevOps, you still have, even in the open source market only, a hell of a lot of tools with completely different kind of configurations which everyone has to be learned. So it doesn't make the things much better. There's a company, Red Hat, which is doing all day designing their stack to help other companies with these things. And even they don't have one tool to do that, but they have a whole stack of managing virtualization, the middleware, the lifecycle, the configuration, and the automation and orchestration. And then there is hundreds of these kind of stacks out there with different alternatives. But how can I manage a big enterprise like ours if this is vendor specific? You understand? So we're heading to do a standard for that. And you know, if there are so many standards out there and you want to make it better, you end up having another standard. That's a little bit of a pity. And so we also have to prevent this kind of pitfall. So we need to do it somehow better. I'm often asked, what's now the best or the newest standard for cloud migration? And I'm often talking about IoT projects, so they ask me, what's the best IoT platform or something like that? What's the newest standard here? But there's a glitch in it. Is it new or is it a standard? So how can it be a standard if it's new? So the question is, what should I approach? The standards are proven, managed, adopted. They are mature, but often outdated because they didn't follow something like a new paradigm like DevOps. Yeah? They were not aware at that time when they created the standard that there will be a better paradigm in future. So the standard is maybe mature and proven and adopted, but wrong. And the new things adopt fast, but they never came across big enterprise scenario issues. And then they realize at some point of time, oh, we didn't know that it's that complex with you. So you end up with a new thing, reinventing the wheel again and again. So the more better question is, what is the most mature way to do something? So not the standard way, not the new way, but the most mature way. Who of you have ever heard about a model which is measuring maturity? Ah, wonderful. There's one model. This is the capability maturity model. Who of you have never heard of it? Ah, quite a lot. It's very good because you can measure everything you do, whatever capability it is, you can measure how good you are in it. So if you do something for the very first time, it's hard to do for you. Let's think your tax declaration. In Germany, that's quite complex. Yeah? Think about doing that for the first time. Every of the questions is a surprise. Oh, I should have these bills on my side now, yeah? So if you did your tax declaration 10 times, then it's repeatable. But to be fully defined, that means all the steps which you will be doing are so well described that you could automate it. That's a far way higher. If you measure how good you are in something in level 2, then each measurement will be different because it's a little bit individual how you do it repeatable. In a defined state, every measurement will be absolutely identically. And only from there on, you're able to improve the system and improve bad results, because 3 implies it's always the same results you measure, but it doesn't say that you can get better. So obviously, in level 1, it means for you, you quickly get messed up with the new things. With level 2, it means you're not that defined and standardized that you can collaborate with the outside world, which has a different worldview and different grown model. On level 3, yeah, you have to get there by learning standards. That's quite hard. And to manage something on the level 4 means that you, for the first time, are really able to contribute improvement to a corporation. So how many of you have ever tried to use that in their organization to improve their organization?
Isn't it called CMMI?
CMMI is the explanation of CMM in a CMM5 level way. So you saw how quickly I can explain it. With CMM5, CMMI, you have an integrated model which is this big, which explains what's the problems of it. So it's over-optimal, over-optimized, Pareto inefficient, as you see. So it's more than we really need. We just need these 5 levels to understand how mature can I be. So the point is we need to stop reinventing the wheels. We need to look what kind of standards have existed and try to map them on the right maturity level. So CMM level 3 requires us to understand patterns and to realize this is a problem which I already solved in that technology at that time, and even if there's a new technology which is solving the same problem, it's still the same thing. Yeah? So we need to understand that we shut down reinventing the wheels. I don't know if you know that there is already the last architecture. We already know everything of IT and architecture. There's a model which is called model-driven architecture, in which you can map any technology to any other technology. And this basically creates a massive diversification of technologies. And you know today, if you ask 2 telecom companies if they are doing the same thing, they would argue, no, no, our technologies are so different, we are not doing the same thing. But basically, you phone with both of them. So we invented this service-oriented architecture, which names the same things, the things which do the same things, the same way. And that closes basically a loop. And we basically already know which technology solves what, where. And this kind of knowledge is very important when you go to big, large enterprise problems. Deutsche Bahn is a holding. Yeah? There's the Deutsche Bahn AG. And there's one IT service provider, the DB Systel, and it's a service provider for all the companies which start with DB. And it's 380. So there's DB Netz, which owns the railway, DB Cargo, DB Schenker Logistics, DB Energy, which is producing the energy. So imagine, this is a whole small world in itself. So we have all the vendors' products, we have all the technologies, and we have to still cope with that, and now we have to migrate it from our data center into the cloud. So we can't think in smaller scale than in a scale which will work also globally. And we have a big problem because most of our infrastructure is dedicated servers, yeah? And now we have to become virtual, elastic, and cloud. Our servers, our applications you saw are distributed complex applications, and now we have to be apps and stores for the future. And then there is this kind of API management everywhere. But finally, we have to do legal contracts with our software and get a ticket which is paid over a mobile phone. Yeah? And there is big processes included in making trains go. And today, everybody wants everything mobile, touch, and responsive. And if it's still using a mouse, it doesn't work. Yeah? But the good news is there's a way to express all software which is existing on the world in 5 levels, these core 5 levels of enterprise architecture. And there is basically the infrastructure level with the hardware and the virtual machines. There's the applications, and you can see here's a mainframe, here's a client-server application, here's a distributed SOA application. And basically that works in any company on the planet to draw a picture of their IT, which they use in these 5 layers. So even the software which we had to create to manage software could be drawn the same way. So our target architecture is drawn in this kind of way, where we exactly see which kind of hardware, file systems, Neo4j and Structr is used, and what kind of services we are creating, and what kind of processes we are using them, and through which GUIs they are available later on. So our idea is that we help people in the IT to describe their system as a small component, and then at first they declare a component. Then this component will generate a project for them where they can put in the legacy software, and then this software will describe what kind of dependencies it has to other software. And finally, you manage a package containing of multiple software components, and just say to the root package, install yourself. And then it goes down, all the other packages, and they are also said, install yourself. So it's self-contained components, which can be bundled together in an application descriptor. So, and here we have the notion of an application. It's basically the 4 layers on top of the infrastructure layer. And here's the platform, our software AG and TIBCO platform, and it contains of components. But finally, we have one descriptor packaging all the other descriptors. And these descriptors are human readable and machine readable in XML. They are quite simple to read even, and very simple to create with our new software. And then you basically have a graphical manager to create software packages and tell them, install yourself somewhere. And then an installation is done, and this installation has configuration values. In these configuration values, they are in one other XML descriptor. All the configuration values of a software are present so that you can see what software is configured where and get full transparency. The wonderful thing is that Structr gives us the possibility to model these complex data structures required much, much easier.
Yeah, thanks so far, Marcel, and thanks for explaining these rather complex things. And our role in this project was quite simple, very, very easy. Simple task. Just take all the things that the team around Marcel had created before, like these descriptors, the data model, which was already there, and just put it into a graph. And we used Structr, the tool we created, or we are developing since 2010. And so this is the data model, which does not look that complex if you compare that to all the different components and elements and scenario descriptors, application descriptors, and so on. It's all in there. So we have a complete model of the whole configuration stored in just a few classes. And that's only possible in a graph model. So that's my, yeah, that's the truth, I would say. So, and now we created a solution called Configuration Data Hub, which is a very broad name, but I think it really fits to the overall goal to manage all the complex dependencies between any components which are described by these descriptors. And the nice thing you can only do in a graph world is you can generate any use case specific view on your data from any perspective in real time. So you don't have to optimize upfront your SQL queries and so on. So there were attempts to do that in a relational database, or even worse, in a non-relational database like a code repository system. And these things are good at storing information in one way, but not querying it in many different ways. So that's one very important goal we only could reach with a graph database. Another very important goal is to detect and visualize patterns, like impact analysis, like one component or one system, one server network component fails. What's the overall impact on the Deutsche Bahn holding? Because at the end, it will be lots of money which have to be spent on repairing things. And if you have doing an analysis on typical patterns and you see where are your single points of failure, then you can manage that up front and create redundancy. And another interesting feature we were able to create is to allow real-time search and updates of your dependencies. For example, these descriptors, these XML descriptors, we store them not as XML files on the graph. They will be deconstructed and disassembled into graph structures. And you don't have a redundancy in the storage. So that means if you create a new version of a software component, then you just bump up the version number, but any other descriptor which references this new version has to be updated as well. And if in a very complex system with many of these things, you end up doing lots of write operations all over your classic database. In the graph, it's just change one value, because any other value just points to that one reference. And with Structr, with our platform, we were even able to create a nicely looking UI, and it allows to have a multi-user and multi-thread environment. So all this was built with Structr around the central Neo4j database instance. So here are some early visualization UIs, and as I said, it stores the entire configuration information in just one graph database. And we have APIs to SVN or the Salt Stack. It's an open source toolkit which is able to communicate with, it's a client server system to communicate with each server to get information about the versions of the installed software, the paths on the system, on the machines, and you even can write back changes in the configuration. So it's kind of an orchestration for to manage hardware and software systems. And there are a couple of applications like ADESC, an internal and intranet UI, which is targeted at configuration managers to just see into the existing network and system landscape. So you can navigate through a graph to see all your installed systems and platforms down to from the applications down to the hardware infrastructure in one graph. And it's very convenient and role-specific, or allows for role-specific user interfaces. That's also something you can do very well with our tool Structr. Yeah, and the overall goal is to create a self-contained, or maybe also multiple self-contained simple systems using or making use of one big logical graph database instance. So what is Structr? Just a few words. Someone very smart once called it the Structr is the Neo4j workbench. It took a couple of years to come up with this term, and we're really thankful to Jim, who mentioned that in a couple of keynotes. So that's basically the essence of what we're doing, and now we're using that in our own marketing. And it's an application development and runtime environment, so you can build graph-heavy or graph-related web and mobile applications in very quickly. And if you want to learn more about Structr, just come out to our booth, and we can help you and give you any information you want to have about this open source platform. Yeah, what's the current status of the configuration data hub project? So there's a prototype built at Deutsche Bahn DB Systel.
The prototype is just creating files to describe software packages and the installations, and you can right mouse click and install it over multiple servers. So we just wanted to create a prototype at first to make it possible to show the people this is possible to do. It's not existing up to now, but it's possible to do. And they immediately liked the prototype so much that it's now in production at Deutsche Bahn and migrating real mission-critical applications from servers to other servers already. But it's written in Software AG software partly, and that's much too expensive, and also it doesn't have this kind of Neo4j database underneath. So they asked us to go into our target architecture and really do that from scratch on top of a Neo4j graph database, because all the dependencies are a graph. And the fastest and most reliable way was to do that with Structr. So we created a company to just get this kind of project out of Deutsche Bahn and create a new version of that, which will be fully based on open source, graph database, and Structr application development environment.
All right, this version is currently under development, and it's even planned to offer that as a purchasable product end of the year or beginning of next year. So because we see really a lot of demand throughout all the big companies who have the same problems. And yeah, that's
so if you know anybody who has the same problem in their enterprise, there's hope that you can get access to this kind of solutions by just querying us.
Right. So that's it. If you have any questions, please feel free to ask. Thank you.